Well, now we're at the very last section of a one problem example regarding one of the most used concepts in statistic, and that is the empirical rule. Empirical means tried and true. So, this empirical rule separates a bell curve, which a bell curve the data is symmetric at the mean. Also, it means the mean and the median and the mode are very close. That it is a bell curve. And the word to imply bell curve is normally distributed. What, are, what is it? What is it saying? All right, this is what it's saying. We've been using the test of 5% significance to test for significantly high or low. And that means that the data is normally distributed and has certain parts to it. So, what are the parts? It means the data structure is X bar in the center. Okay, and then from that point, X bar plus S equals Q1 value. X bar plus 2S equals the not I shouldn't say Q1. I shouldn't say Q1. I'm sorry. I'll get you confused. Is the first standard deviation. I'm going to write out the language. First standard deviation. One. I should say one. My brain is maybe hungry. I don't know. One standard deviation um, above the mean. And remember that standard deviation is constant. And then we'll have X bar plus 2S's is 2 standard deviations. and we go to 3, and, we have infinite many. And we've done this already where we do the negative of it. So then we also have the x bar minus s to get us to go this way. Well, what else is unique about this plan? Okay, what is unique is that the area under the curve equals 100%. All right, it means all of it. So we can approximate very accurately percentage values by standard deviation location. And done to the whole partition. In other words, it's either one standard deviation below the mean, how much area is there, or it's two standard deviations around the mean, which is there, but it cannot be anything that is hard to predict. You can do 1.5, but you cannot do anything um, uh, that is going to be difficult to calculate the amount of area. So what does this mean? Well, I'm going to expand this so you can see it, and we'll discuss it. All right. So if we were saying one standard deviation around the mean, that means from there to here. I should have done it on top. Let me do it on top. And we would get the beautiful 68%. One standard deviation around the mean. Okay, then if we do two standard deviations around the mean, that one's another popular one because that is where our significant values come from. Then, oh, sorry, didn't go far enough. I did that. Sorry about that. Then we have approximately 95%. And what is the difference of 100 minus 95? 5%. So those are the critical areas or outside of the middle condition area that we've been doing. And then if we do the third standard deviation, and I'm not going to do it, it is, well, I will, but it is almost all of it. And that is 99.7. Now you can have partial amounts of these guys because of, and I noticed that this one that I got has a little more extra on it. We're just going to divide the 68, the 95, the 99.7 into whatever amounts we need. But I got this off the internet. All right, so let's look at our problem. And I'm going to draw. The blood platelet count of a group of women have a bell-shaped distribution with a mean of 254 and 8 tenths and a standard deviation of 64 and 3 tenths, all units in 1,000 cells per joule. All right. Using the empirical rule, find each approximate percentage below. So we're going to draw our bell curve. We're going to mark our mean. And our mean, sorry about that, we have a value, sorry, and I made that too long. Let me try it again. And our mean is 254 and 8/10. So this is 254. Oh, I'll put it as a, okay, I'll do this. That's great. That's what we're going to do. Okay, so we know that x bar plus s is our next value. So that's going to be 254 and 8/10 plus 64 and 3/10. So let's do our math. Three, 1, 9, and 1. All right, so that's one standard deviation. Then our x bar plus two s's is our next break. So that's going to be 254.8 plus 2 times the 64.3. All right. Oh, sorry about that. Plus 2 times the 64.3. Making sure I've got it correct. Okay. I don't want to make a mistake on your notes. 383 and 4/10. Okay, so that's our next number. And then our third standard deviation is 3 times our S. So I'm going to do a second entry and come over here and put a 3. Right. Well, that takes care of my right side. So let's put that in. So this guy right here is 319.1, 383.4, 447.7. So if I go to the left, I have to subtract. So we're going to find those values. X bar minus S. That's 64.3. Just make sure. So this is that. And I'm going to get a value. And then I'm going to have X bar minus 2S. So that one's going to be and then I'm going to have the third one, X minus 3S. All right, so let's do this math so we can get it posted on our bell curve. So there we go. I'm going to do a second entry and put it, instead of a plus, I'm going to put it as a minus. Oops, sorry. Minus, not a negative. Okay. And I get, let's do that. 61.9. Now I'm going to do a second entry and put minus 2 times that. I'm going to hit enter. 120, 126.2. And then I'm going to do the 254 and 8/10 minus 64 and 3/10. And I'm going to get 190. All right. Now, I drew my bell curve so that I know that this is my X bar. These are positive standard deviations to the right. These are negative standard deviations to the left. All right. So let's see what the question is. What is the approximate percentage of women with platelet counts 2 standard deviations around the mean? So this is 1, 2, and this is 1, 2. So 2 standard deviations around the mean is 95%. What is the approximate percentage of women with platelet counts between 61.9 and 447 point? Well, that's 3 standard deviations around the mean. So that puts it at 99.7%. I thank you so much for listening. This is one of the fundamental reference tools we use in statistics if it is a normally distributed. Thank you.